Thank you very much, Alex. Hello, everyone. So we can get started. So today we are going to talk about fault-tolerant applications, what it is, and how to build them. My name is Sergei. I'm working at Hazelcast at the Cloud Native team. We are making Hazelcast Cloud Native. So let's get started. But before talking about fault tolerance, I would like to tell one story about one space program, which was called Mars Climate Orbiter. This program was launched in 1998, and it was supposed to arrive at the orbit of Mars in 1999. It was supposed to arrive at the distance of 226 kilometers from the surface of Mars. And it was the mission of this program was to study the weather and the climate of Mars. Instead, it arrived to the surface of Mars on 23 September of 1999, but it entered the atmosphere of Mars at the distance of 57 kilometers. And since it wasn't supposed to enter the atmosphere, it got destroyed, burned in the atmosphere, and the mission was failed, basically. Um, if we are talking about fault tolerance, there are three terms that we have to know, which is fault, error, and failure. First one is fault, which is some defect in the system, some bug that is there. It's just there, and we are not supposed. User doesn't know about it yet. The problem with the Mars Climate Orbiter, which I mentioned earlier, was using the two teams that built this program was using different metrics system. One was using metric system, and another was using English measurement system. And it was the fault. Just using this was wrong. The next one is error. This is something which is incorrect behavior. In case that is caused by default, so bug which user can see. So in case of Mars Climate Orbiter, entering the atmosphere of Mars is an error. And the failure when the system is broken completely and the application doesn't work. So in case of Mars Climate Orbiter, destroyed orbiter is basically a failure which failed the whole mission. But what does it mean to be fault tolerant? Does it mean that the application, the system should not have any faults and it should be just ideal without bugs? Of course not, because every system will have its bugs. It's not possible to have a system which every time works correctly and just not to commit any bugs. And to display that, I want to show you, to tell you about other space program, which is, you probably heard of it, two rovers which was sent to Mars, which were Spirit and Opportunity. Both of these rovers were sent to Mars in 2003 and arrived to Mars in 2004. Spirit was arrived at Mars and was supposed to work there for 90 sols. Sol is like a day, but on Mars it's slightly longer than a day on Earth. Instead, it worked for 2,210 sols, which is 5.5 years. So it's much more than it was supposed to. An opportunity, more incredible, it worked. It also was supposed to work for 90 sols. Instead, it worked for more than 5,000 sols, which is about 15 years on Mars. Does it mean that during this period they didn't have any problem? It was like perfect. Everything was working according to plan? Of course not. They had some problem with the wheels, which make them move backward, with some manipulators and many other problems. But even though it worked much more than it was supposed to, and that's what fault tolerant is about. Even though there will be some problem, the system should continue to work and should continue to operate, and the user should not suffer because of that. And today we're going to look at how Kubernetes and Istio can provide us the fault tolerance features, and how can they make our applications more fault tolerant. This talk aren't just Kubernetes and Istio specific. So if you don't know about Kubernetes or Istio, don't worry. I won't go deep into what it is, but I will just briefly explain it. So Kubernetes is an orchestration system so that you can declaratively just say how to run your application, and Kubernetes will take care of it. It has its control plane, and it will make sure that your application is deployed across your cluster, will make sure that it will take care on which node to deploy it, if it needs to reschedule it. Istio adds another layer of abstraction. It also has control plane, and to each instance of your application, it will add a proxy, and all the traffic will go through this proxy, and this can give us a lot of more features that we will see today. Okay, so enough talking, we can start exploring Mars. But before this, let's see what do we need for exploring Mars. First of all, we will need a rover. Rover will talk to ground control and will receive its name and the coordinates of other rovers from ground control. Instead, it will send his coordinates. But Mars is not very welcome environment. It can be dangerous, so we need some orbiter that will tell our rovers about some meteors that can hit him, and if there is underground water that he can explore. And we have also ground event lander that will receive data from events lander and from ground control to tell our rover if there are any dust storms or maybe any alien form of life. You may wonder what I'm talking about, because that's not about Kubernetes and Istio. This is, in fact, a game which I have built to show you the fault tolerance feature of Kubernetes and Istio. So our rover will be our browser, and we have three microservices, which is player service, event service, and ground event service. And also we have Hazelcast cluster for storing the state from the player service. So rover will send his score to player service and will receive the name and the leaderboard. Okay, let's see how this game looks like. Okay, so this is the game. You can see that we have a rover, we can move forward. There are some meteors that are falling from the sky. There are aliens that we can collect. Meteor can hit us and we will lose all on life. We can scan for underground water. And there is a dust storm. If we hit it, we will also lose 1 life. When we lose 3 lives, the game stops. So you can see here we have leaderboard. So I was playing for Apollo from Orbital Science, and I've scored 97. Okay, so everything is clear. Let's try to deploy the new version of our event service. So we have introduced some new features. From the name, you can see that it won't go as smooth. We can see that the new service is being deployed. And let's continue playing. So after some time, we can see that there are no events anymore and something is wrong. But now we already received meteors and other events as planned. So we can understand that something was wrong. The simplest thing that we can do is to go and see our services. Okay, just a minute. So we can see the event service. It has 1 restart. That was the problem that we had. So our service crashed, and this is something that you get for free from Kubernetes. Whenever your service is crashed, it will self-heal and will bring it up again. But here we have one problem, which is the fact that we don't have any other instances. Okay. Just a minute, sorry. We don't have any other instances whenever our service is crashed. So no other instance that can handle our request. So we can scale it up to 2, 3, I guess 4 instances should be enough for us. And we can see that for now, we have manually scaled it, and we now have 4 instances of our service. Not every instance is started, but anyway, we have 4 instances. So now, when we are playing the game, we should not face anymore this issue, because we will have the redundancy. We will have multiple services, multiple instances. So user won't notice this error. So if we see at our services, we can see that this one is crashed, this one is crashed, this one has already one restart, but user didn't notice that. Okay, now let's deploy a new version. So the problem was probably fixed. Let's deploy this new version. Let's make sure that it's getting deployed. Okay, so we have the new one which is starting, this one are terminating, everything seems fine. Yep, we can continue our game. So now we are still playing the game, everything seems fine. But after some time, we should face the error again. Yeah, so here it is, no more meteors. So again, something is wrong with the game. But this time, when we are looking at our instances, we can see that it's not restarted. Our event service is not restarted, so everything seems fine. The problem here is that not every time when something goes wrong, not every time the service crashed. So the process might be running, but it might hang for any reason. Maybe there are some exceptions, maybe anything might happen. And in this case, we should tell Kubernetes that in fact something is wrong, and you have to and our service is not alive even though the process is running. For this case, we need to apply event service. We need to apply health checks. Yeah, my bad. Okay, so we have applied health checks, and now our Kubernetes will know that, okay, it will get redeployed. Let me start the game. Okay. Now we will still face this error because we have the same version of our service. But if we check our service, okay, we didn't yet face it. Okay, so now we don't receive the events, of course. And yeah, now there are. Okay, so if we check our pods, we can see that now we have one restart. And now Kubernetes know that, okay, I see that your service is not responding, so I will restart it. Okay, so let's go back to our presentation. Clean up it first. And let's see, let's recap what we just seen. So first thing, it was the self-healing mechanism of Kubernetes, which will make sure that you always have your application up and running. And also you can scale it to any number that you need. And Kubernetes will make sure that this number of replicas will always be up and running. But this was with the okay, before this, let's see some numbers. So why do we need redundancy and why it's so important? So imagine that we have one instance of our service, which is available 99% of the time. The 99% seems pretty good number, but in fact, it means that we will have 3.65 days per year of downtime. If we just scale this application to 2 instances, our availability will increase to 99.99, and the downtime will be only 52 minutes per year. And increasing it to 3 will bring us to the famous 6 nines, which will make the downtime decrease to 31 seconds per year. But this is for the manual scaling. but sometimes we need to react to some events. Maybe there are some unexpected increase in traffic or anything else that we need to react without manual intervention. So for this thing, we have auto scaling, which Kubernetes provides. And we have three types, which is horizontal pod autoscaler, which will just increase the number of instances. Vertical pod autoscaler, which will increase the resources for the given instance. And cluster autoscaler, which will increase the number of nodes into our Kubernetes cluster. And we have seen the health checks, which are liveness probes, which will tell our Kubernetes if our application is alive or not. It's a readiness probe. In this case, the application won't get restarted, but just will stop receiving traffic. Maybe it will get back after some time, maybe just some load that it couldn't handle. And the startup probe for the application that starts not that fast. Uh, Here is a simple specification how you can configure it. So this is for readiness probe. Startup and liveness probe are pretty similar, just a different keyword. But this is for the stateless application, for the ideal world of stateless application. For stateless application, each instance is interchangeable, so they are the same. You can every time connect to any instance, it will be the same. Unfortunately, in the real world, we don't always have stateless application. We need to handle the state somewhere. And for this thing, we have stateful applications. And with stateful application, that's not so easy. If some instance crashes, you cannot just connect to a new instance in the same way like it was before. So for stateful application, Kubernetes have some additional features, which is a stateful set. And it will give you some options how to build your stateful application and how to run it in Kubernetes. So for this thing, you have unique identity, which will make sure that each instance has its own identity, and you can just address your instance and make sure that it's the same. It has the mechanism of sharing its own state. So for the pods, if you are sharing the state, it will be shared between all instances. But for the stateful set, it will have its own state. And it has also a fixed endpoint. So if the application crashes and started again, you will have the same fixed endpoint that you can connect to your instance. So it's a bit more harder than for stateless application because you don't have everything out of box, but you have this set of features that will allow you to build your stateful application to run in Kubernetes. For example, as I'm using in my demo Hazelcast, we have a Kubernetes plugin for Hazelcast, which uses this feature to make sure that Hazelcast works inside of the Kubernetes. Okay, so we've seen some problems which we knew how to identify, but usually that's not the case in the production. So something happens and we need to first understand what and where does it happen. So for this thing, we have Istio monitoring features. So as I said, we have proxies along each instance of your application that are collecting a lot of monitoring data and send this data to Istio component. And then you can connect it to different tracing metrics, logging, or any other tools for just receiving this data, and you have telemetry out of the box. Okay, so let's go to our application again and see how does it work. So let's deploy a new version this time of player service, which is responsible for our leaderboard. And let's go to our game. We can restart the game. You can see for now everything works fine. But we can see that our leaderboard starts to disappear. So it's not there anymore. Okay, if we continue playing, yeah, it sometimes appear and then there are any other errors. So definitely something goes wrong. First thing that we can do is go to Grafana. This is Grafana, which is configured by default with Istio add-ons. So I haven't configured anything else. It's the set of metrics that is already collected. And if we go to our incoming success rate for the player service, we can see that it's not 100%, but it's also not zero. It's like 76%. So we are having these errors, but they are not like constant. So if we could just retry our request, then there are pretty big chance that it will work. So what we can do, we can just apply retry player service. This is a configuration for Istio without making any changes. Yes, why? Without making any changes to our application, we can just fix this error, at least for our users. So it will still be there, but our users will stop noticing that something is wrong. So as you can see, leaderboard is not disappearing anymore. But if we take a look, our success rate is still not 100%. We are still receiving some errors, but users don't see it anymore. Okay, let me deploy another version of event service again this time. Let's make sure it's getting deployed. Yep, code initializing. So we can get back to our game. So we are continue playing, and we can see that there are problems this time with the ground events. We don't receive any aliens, any dust storms. So again, something is wrong. And it appears after some time. So what we can do, we can first of all go to our ground event service. We know that this is ground event service. And one thing that we can see is that there are some slow responding events. So we can see that there's like more than 1 second. Not sure that this is caused by this one, but again, we can see that again, there are no new ground events. So if we refresh it, we can see, yeah, there are now events that are responding like up to 30 seconds. Let me increase it. So we can see that there are 30 seconds response time for the request. But it's not for every request. So we can see that some requests are faster, some requests are slower. Okay, let's take a look to our ground event service, the traces, the distributed tracing. This is again Jaeger, which is available by default. So here is our request. And we can see that the problem actually is not in the ground event itself service, but in the event service. So the event service is slow. And what we can do, since we know that not all the requests are taking up to 10 seconds, we can, instead of waiting for this 20 seconds, we can just set up some timeout and just send another request, because we know our application will just send another request. But we can just set up this timeout and wait for maximum, I don't know, 1 second or something. So again, configuring Istio. So this is, again, just the Istio configuration. I have set up this timeout. Restart the game. And now, okay. So something is wrong, not expected. Let me check what was the timeout value which I set up. It should be half a second. What is with our event service? It's running. Okay, let me see what will happen this time. So this time we will receive events. Okay, restarting. So seems like, yeah, it was maybe some delay in the configuration. But now we can see that we don't receive this delay for the ground events anymore. So there is some slightly delay because we're waiting for half a second, but still it's not like 20 seconds. If we take a look here, refresh, we can see that the requests are pretty fast again. And in the tracing, we can see that we are now receiving some errors, which are like after half a second, we are receiving process. Okay, it should be the timeout error. Cannot find the error code, but this is timeout error after half a second. Okay, so let me clean up this again, and we can get back to our presentation. So what we have seen is the resiliency feature of Istio, which allows you to configure timeouts, retries for the failing requests, and timeout for the requests that take too long to respond. And there is something that also could help us in the scenarios that we've seen, which is caching. You might have expected that I can tell you that you can use Hazelcast for caching, but unfortunately, Istio doesn't support third-party resources for caching for now. So you cannot use Hazelcast to connect it to Istio for now. But most of us already using some mechanism that have pretty strong caching tools, and this is called HTTP. And the thing that I want to talk to you about is cache control header, and specifically two options, which is stale while revalidate, which makes your browser getting the stale result from the cache. Meanwhile, the cache will send an async request to the service to update its values. So this could help us in case with our slow event service, which are which was responding slow. So we can get the old results and display it faster. Meanwhile, the cache could update the new values asynchronously from the service. Another option is stale if error. So this makes the browser, in case of receiving the error from the service, get the old stale results from cache. So this could help us with the leaderboard, which was sometimes with error. So we might display the old results instead of showing the errors to the users. This is how the configuration would look like, just to set up the headers for Istio to every response. But there is one problem with these options, and the problem is called browser support. As you can see, stale while revalidate is not supported by all the browsers, and stale if error is not supported at all. And this feature are experimental, but when it gets mature, we can use it and it can help us. Another thing that can help us is circuit breaker. So imagine that we have some service and we know that this service can handle 5,000 requests per second. And something happens, our service gets very popular, and instead of getting 5,000 requests per second, we are getting 15,000 requests per second. And our service will just crash and all the users will see the error. Circuit breaker can set up some limits for our service, and we can say that our service can handle only 5,000 requests. And for example, 2,000 requests can wait in the queue for available slot, and all other requests will just receive an error without even getting to our service. With this approach, some users will still get the error, but at least 5,000 requests that our service can handle can be served and can respond with success. Another option could be rate limit, which is in case of circuit breaker, it's like more global configuration, but with the rate limit, you can set up this limiter for user, which is very useful when you have some public API. And you can set up how many requests user can send, and all that exceeds this limit will just receive an error. And moreover, you can set up a different type of users. For example, if you have some premium users, you can increase this limit. You can double it, whatever you want. Okay, but how do we know that our application is fault tolerant after we set up every feature? How do we know it? With the code, it's pretty simple to make sure that it will it doesn't have bugs, that it will handle some errors. You're writing tests. The same goes for the fault tolerance of application with the chaos engineering, which is technology, not technology, but rather approach popularized by Netflix with their tool Chaos Monkey, which were going to production and just kill some instances. And now Netflix have the whole army of different monkey, which is called Simian Army, which do some different nasty stuff to their service, so they can test that it's working fine. And they are doing it in production. But if you're not doing chaos engineering already, it's not a good idea to just get these monkeys and just make go it to your production, because most likely your service won't survive after this, at least in the first time. So the good thing is to start by small steps, and Istio allows you to do that. With the small steps, with the fault injection mechanism, without any changes to your application, you can configure some errors to your services or some delays to emulate some latency, some network delays, and you can test how your application will behave in this case. Okay, so before going and trying it, I have this link which you can scan, or you can just type explore Istio demo XYZ, and you can play my game while I will show you some chaos engineering, because as I said, the best chaos engineering is the one that you are doing in production. And even though I said it's not a good idea to start in production, I will do it like that. So for now, you can scan this application, this QR code, and play my game. Okay, I will wait for a bit. And maybe I can also send the link. Oops, this was an old one, by Josh Long. Let me send the link to the chat. Did I send it? Okay. So, okay, I hope you scanned this and we can play the game. So first of all, let me apply some fault injection. That would be a board player service. So we will emulate the things that we have seen already with the leaderboard, but without deploying a new version of the application, but just instead deploying, instead we are just trying to do it with the Istio configuration. So we can see that our leaderboard is blinking again. But again, this is not the new version of application. This is a working one. We can just test what will happen and how our application will behave, what will experience our users. Another thing which I can deploy, CTL, this time fault injection delay event, which is, as you may guess from the name, which is the delay to the event service. Again, without deploying a new version, we just configured some delays to the event service. You can see we are not receiving any events anymore. So there are some delay, and here it is. Here's the meteor, just one, and then again the delay. So as you can see, without doing anything, we just can test how our application will behave and make sure that it will sustain these errors, and it will, the game, in this case, the game will be playable. Okay, so let me clean up this thing. So we have the game. Okay, so I can see that there is one leader, which is Dionysus from Rocket Lab. So whoever is playing for Dionysus from Rocket Lab, please contact me after the session or contact. Okay, so we have now two leaders, but since I already said that Dionysus will have is the winner, but now Hermes is the winner. So, okay, Dionysus and Hermes, please contact me after this session because I have a present for you. Okay, so Now that we have seen the chaos engineering, I want to talk about my game and the fact that I have talked with some people, tried to understand if my game is good or not. And in fact, I have received the feedback that it's not very realistic because, for example, the meteors in real life, they don't behave like this. For this thing, I have the new version of event service, which I will deploy right now. And we can see that my game will become more realistic. Okay, so we are waiting that it's deployed. And probably we can already try to play the game. It will get deployed using rolling update of Kubernetes. So we should not receive any downtime. Okay. Okay, so we don't receive. Probably it's not yet started. Okay, yeah, it is. So I have deleted my delay, I hope. Okay, so my UI is getting slow. As you can see, I'm not the best UI developer. Okay, yeah. So now we are playing the game and we can see that the meteors now behave like the real ones. They are not slow, they are moving pretty fast, as you would expect in real life. Now my game becomes much better, right? Of course not, because for now it's not playable. You cannot play with these meteors. So I was just moving and I already lost 2 lives. So yeah, it's not possible just to dodge them. Okay, so let's go to our presentation and see that we have used, first of all, the rolling updates mechanism of Kubernetes to deploy our application, which will allow you to start the new version one by one without any downtime. And we can just roll back it in the same way. The good thing with our application is good news is that we can roll back it to the old version. And the bad news is that everyone who was playing my game received this new version, which is not playable, and they've seen this bug, this I don't know, this outage of my application. So the better thing how to deploy the new version would be using canary releases, which will allow us having two versions at the same time. And instead of sending all our users to the new version, we can just send one small percentage of user, for example, 1%, or maybe some specific users, for example, the ones that are using mobile browsers, or maybe the ones that are located in specific region or something. In this case, we will still have a real feedback from a real users, but in the worst case scenario, we will use just this small percentage of the users. So let's see how it's done. So first of all, we can undo our rolling update, which you will see will just get up the new version, the old version of our application. You can see the new one is initializing and the old one are terminating. So in this case, after some time, you can see that we already are receiving the old version. So this is the good news. Now we can try to deploy our application, try to apply our canary release, event service version 2. Okay, so it's getting deployed. You can see that we now have three old version of our event service and one with this v2, which is a new version of our application. And if we are playing the game, for now, we will get just load balancing between these versions. More often, we will receive the old one since we have three instances. So you can see it's usually three old one and new version 2. Okay, so now let's apply our canary release. Okay, so canary deployment. And we can apply it for the rovers which are from orbital science, for example, since I'm playing for orbital science now. Let's do this. Okay, and let's apply. Canary deployment service, okay. So now orbital science, the rover from orbital science. Okay, there are some errors, I assume, with this service. Okay, let me refresh it. Now I'm from space dev. Let me change it. And let me apply the new configuration. Okay, so now since I'm from the space dev, I will receive only the new version of my event service, the new meteors only. And if I will lose the game, which is not that hard with this version, and restart it now, since I'm from Rocket Lab, I should receive only the old version. So only space dev will test my new version of our application, of our event application, and we can have the real feedback from real users. Meanwhile, most of the users will play this old and the version that we are know for sure that it's working. Okay, so let's get back to the presentation. Okay, so what's next? We have seen how to use Kubernetes and Istio and what features to bring the fault tolerance we have and how it will help us make our application more fault tolerant. But is it enough? Shouldn't we care about our application at all? Shouldn't we just just offload every fault tolerance feature to our infrastructure layer and don't implement it in the code? And the reason, the answer is no, of course, because fault tolerance should be applied on every layer. And even my application has some fault tolerance features implementation inside the code. For example, in my UI, I don't crash the UI when something goes wrong, when the leaderboard is not returning. I'm just hitting it. The same with events. So, for example, if we are receiving some timeout error, I'm just sending another request. So this is some retries which I have implemented in the code itself, because this is something that infrastructure cannot know how to behave in this case. And how to do it, I can suggest you this great talk from DevOps Ukraine, from Nikita Prutsenko and Alex Borisov. They are explaining it how to implement fault tolerance features using gRPC and REST. And another thing is this great book, Patterns for Fault Tolerant Software by Robert Hanmer, which is not a book about technology, but about the practice. So even though this book is not the brand new one, it will always stay topical. So that's it. Here is the link for my code for my demo. I will share it in the Twitter, so you can find the presentation and the link for the demo there. So thank you very much for your attention. Thank you very much for visiting my talk, and thanks for having me at the Vox Days Romania. Yeah, that's it. Thank you very much.